So today, we're going to unpack this really powerful way of thinking, a framework for looking at pretty much any problem, big or small, and solving it with the kind of pure logic that computers use.
You know the feeling, right? You're staring at some huge, messy task. Maybe it's a big project at work, or planning an event, or even just assembling some furniture, and you just have no clue where to start. It's that feeling of being completely stuck.
What if you could borrow that structured, step-by-step thinking from a computer? This isn't about turning into a robot. Nope, it's about using that same clear logic to make our own thinking sharper and more effective.
Now, there's a formal name for this kind of superpower. It's called computational thinking. And believe me, this isn't just for software developers or data scientists. This is a problem-solving process for absolutely everyone.
So what is it really? At its heart, computational thinking is just a method. It's a way to take a really complicated, messy problem and break it down into a series of simple logical steps. Steps so clear, even a machine could follow them.
To get good at this, we're going to build a mental toolkit. And inside this toolkit, there are 4 fundamental skills. We call them the 4 pillars. And these are going to change how you look at pretty much any challenge.
All right, so what's in the box? We've got decomposition, pattern recognition, abstraction, and the big one, algorithms. Don't let the words intimidate you. Once you get these 4 concepts down, you'll unlock a whole new way of solving things. Let's start with the first one.
First up is decomposition, and it's exactly what it sounds like. When you're staring up at a mountain of a problem, it feels impossible, right? Well, decomposition is just about breaking it into tiny, manageable hills that you can climb one at a time.
For example, just saying build a birdhouse sounds like a whole weekend project, right? It feels big. But what if we just said, hey, let's sketch out a design? Easy. Let's make a list of materials. Done. Let's cut the first piece of wood. Totally doable. Each small step is achievable, and when you put them all together, the big goal gets done without all that stress.
Okay, next up is pattern recognition. And honestly, you do this all the time without even thinking about it. Every time you notice that traffic is always bad at the same spot on your way to work, or that your computer always slows down when you have too many tabs open, you're recognizing a pattern, and that lets you predict what's going to happen and solve the problem faster.
Then we have abstraction. This one sounds complicated, but it's really just the art of ignoring the junk you don't need to worry about. You don't need to understand how the power grid works to flip a light switch, do you? You just need to know, switch up, light on. You've abstracted away all the complex details to focus on what's essential. And that brings us to the final piece of the puzzle, the one that puts everything together, algorithms. This is where you create a precise, step-by-step plan to get from problem to solution.
And honestly, the best way to think about an algorithm is just a recipe. It's a set of super clear, step-by-step instructions. If you follow them exactly, in the right order, you're going to get a cake every single time. No guesswork needed. That's an algorithm.
Okay, so we have our idea. But how do we actually sketch out that recipe before we start throwing ingredients in a bowl? That's where 2 amazing tools come into play, flowcharts and pseudocode. For anyone learning this stuff, these are your best friends for planning and finding bugs before they ever happen.
It's super simple. Flowcharts, they're the visual learner's dream, a literal map of your logic with shapes and arrows showing the way. Pseudocode, that's for the writers. It's like writing out the steps of your plan in plain, structured English, a picture versus a script. Both get you to the same place, a clear blueprint for your solution.
So check this out. Here's a simple flowchart. We start, we get a number, and bam, we hit this diamond. Now remember this, in the world of flowcharts, a diamond is always a question, a decision point. In this case, when we divide the number by 2, is the remainder 0. If the answer is yes, we go this way. If it's no, we go that way. It's a visual roadmap for our logic.
And now, look at this. It's the exact same logic we just saw, but written as pseudocode. See that if, then, else part? That's doing the same job as the diamond. It just lays out the logic like a set of simple instructions. This is so incredibly useful for planning your steps before you even think about writing actual code.
All right, you've made your plan. You've got your flowchart or your pseudocode. But does it actually work? Before you waste a ton of time building something with a flaw in it, you've got to test the blueprint itself. This is called a dry run, and honestly, it is your #1 secret weapon for catching bugs early.
So what is a dry run? It's literally you pretending to be the computer. You grab some test data and you walk through your plan, one step at a time, writing down what happens. I'm telling you, for anyone learning to code or just to solve problems, this is a game changer. You find the flaws in your thinking before it ever becomes a real problem.
You know what? Let's just do one right now. Here's a really simple flowchart. Its only job is to take two numbers, n1 and n2, and figure out which one is the maximum. Let's see if the logic is solid.
Okay, step 1. Let's pick some numbers. We'll say n1 is 10 and n2 is 15. Got it? Step 2, we hit the decision diamond. The question is 10 greater than 15? Well, no, it's not. So, step 3, we follow the no path. Step 4, the instruction there is set max equal to n2. So max becomes 15. And finally, step 5, the flowchart tells us to output max. The result is 15. Is that correct? Yes, the logic works.
And that process we just went through, breaking it down, making a plan, testing the plan, that is so much bigger than just coding. This is a fundamental skill you can use for literally anything.
I love this quote from Einstein because it just nails it. The real work isn't rushing to build a solution. The real work, the smart work, is in spending the time to deeply understand the problem and plan your attack. That's the heart of computational thinking. All right, so let's wrap this up. What do you need to remember? First, take those giant problems and chop them up into little pieces. That's decomposition. Second, create a super clear step-by-step plan. That's your algorithm. Third, draw it out or write it out using a flowchart or pseudocode so you can see it clearly. And fourth, and this is the big one, always test your logic with a dry run before you do anything else.
And look, this isn't just theory for a computer science class. Think about it. Planning your weekly budget, optimizing your study schedule, even figuring out the most efficient way to pack a suitcase. These are all problems just begging for a good algorithm. So I'll leave you with this. What's a problem in your life that you're going to go design a solution for?